And welcome to section 1.2. Last night you were asked to read, last night over the weekend, right? To read and highlight section 1.2. Let's just start by talking about what you read and what you learned, okay? There was basically two big things in section 1.2, and then a third thing that you just kind of don't realize it was there until we look at the title. What was the title of the section? Graphing functions, right? How much did it actually talk about graphing functions? Huh? What were we doing the whole time in section 1.2? They were talking about, all right, so what were the big two? Charts. What charts? Input, output charts. Anybody got another name for input, output chart? Anybody? Anybody? How about a T-chart? Ooh. And remember, if I write something down, I think you should, right? The T-chart. The T-chart's an input, output chart, yeah? Got another name for one? How about a lazy T-chart? Anybody know what a lazy T-chart is? Yeah, the one that's on its side. It's laying down, therefore it's lazy. Get it? Don't worry here. I'll be here all week. Okay. Lazy T-chart. And anyhow, we're talking about inputs and outputs. The whole reason we do a chart is so that we end up with sets of inputs, outputs, also known as coordinates or ordered pairs. And then once we have a bunch of those, we can plot them on a graph. Why? Why would we want to do that? Why do we want to graph this stuff? How many solutions? I get this simple equation here. F of x equals x plus 3. Let's just look at this nice, simple equation I have right there. You see it? Okay, so how many solutions are there to that one single, simple little equation? Wow, you guys are just all over it today. Yeah, there's an infinite number. Like, for every input you give me, I give you a new output. 1, 4. Give me an input. 2. Oh, okay. 5. 7. 10, right? There's an infinite number of solutions to this one simple elementary little equation. How would I possibly list all those? In a chart? You want to list a chart with an infinite number of numbers in it? You don't? No, you didn't even want to read and highlight last night, did you? How long would it take me to list all the answers when there's infinite answers? I hate to break it to you, but we would actually die before we finish the list. How many of us want to spend the rest of our lives listing out the answers to one simple math problem? Nobody? Oh, okay. How much am I getting paid? Nothing. No. Okay. Well, what we can do is we can instead draw a graph and allow the graph to be a visual representation of all the possible answers. Well, doesn't that make sense, right? And that's the whole point behind graphing, is just a visual representation of all the possible answers. Okay? So anytime that we're given any type of equation, we can use a chart, choose some inputs, plug them in, get some outputs, graph them, and have a visual representation of all the answers. That's cool, right? Well, that's what section 1.2 is about. That's the first thing, is input-output charts. Okay. Now let's talk a little bit more about about input-output charts, because you're used to seeing them like this. You know, the input being the X and the output being the Y, right? And we now started talking about function notation to where it's X And instead of y, we would use what? F of x. Yeah, okay, we're waking up a little bit. All right. Yeah, we would use f of x. Means the same thing, right? F of x is y. It's the same thing. So it can look like this now. And that's cool. I want to talk a little bit more about it because we're not going to use just x and y. Okay? We're going to use other things. I know you guys like looking at my face, but I'm going to get rid of it. Okay. See, the independent variable is which one? X or the y? Which one's the independent variable? This is not a trick question. Yep. It is the x. The x value. It is also known as the input. Okay. It is also known, anybody else? What is the set of all possible inputs? The domain. Good. All right. And then what's the dependent variable? Because I want to know. What's the dependent variable? Say it again. Because I want to know. Yes, it's the y. Did you get that? It's the y. What do we call it now? Because we know about function notation. We don't just call it y, we call it f of x, right? Right? That's the same thing. It is also known as the output. And finally, the set of all the outputs is known as the, come on, somebody speak up. Yeah, there we go, the range. Okay. The range. I want to go back to that simple problem. I don't want this one. I want the simple one. See, because sometimes we're going to have a simple equation. Instead of using x and y, we'll use, in this case, c. Okay? Does that change anything? Does that mean something's going to be different because I'm using different letters? It's kind of like function notation. Right now, we're used to seeing f of x, but does it have to be f of x? Can it be g of x? Yes, it can. Could it be h of x? Yes. Could it be I of x? Well, it could be, but you won't ever see that one because I has a specific thing for us. So function notation can look any of those different ways as well. Okay? And that's cool. But so now I have an input. I have output. I get to choose whatever values I want to put in for my inputs. You've probably used these four numbers a lot. Yes? Why? Why do you use these numbers? Because they're easy. I mean, 0 times anything is 0, right? I mean, 0 is just really easy. 1 is super easy because 1 times anything is that number. 2, still an easy number. We know all of our 2 multiples, right? What's 2 times 10? And everybody said 2 times, here's a really rough one, 2 times 56. Come on, 2 times 56. Come on. 2 times 50. It is 112. Good. See, you can even do that one in your brain, right? That's why we use those ones. And then 3's next. I do want to, I'll come back to that in a second. So we can plug those in, right? And we have to go like this. F of 0 equals 0 plus 3, which is, anybody said? 3. Oh, we gotta get good at this, like back and forth, okay? So it's okay. If I ask a question, you can just say the answer out loud. So what do I do next? Glad A. Plug the next one in. F of 1, which is 1 plus 3. And 1 plus 3, and it is 4, right? That was easy, yeah? So F of 2. I do want you to notice that every time I'm plugging something in, what am I doing to it? I'm putting a parenthesis around it. Yes? We talked about that the other day. Make sure we put a parenthesis around it every time we plug it in. 2 plus 3 is 5. Do you see the pattern happening here in our outputs? What's the next one going to be? It's okay for you to see that pattern and finish it that way too, instead of doing the work. That's allowable. Okay. So now that I have all these points, I could simply graph them. 0, 3, 1, 4, 2, 5, 3, 6. Boom, there's my beautiful straight line. I didn't miss the points or anything. Right? That is an input-output chart. You've been doing that since what? 5th grade? Anything new there? Okay, anything difficult? All right. I am going to tell you this, though. Notice on my inputs in this problem, I used 0, 1, 2, 3. I would like to do the exact same problem. I'm going to use a lazy t-chart here. Oops, not X. I got C and F of C. And I like that we used 0, 1, and 2. But I would like to really make a habit of looking on both sides of the y-axis. Could I use a -1 and a -2? Can I do that? Okay, let's do that. So I already did half the work here. Did those 3. So 3, 4, and 5. If I plug in -1, what do I get? If I plug in -1, what do I get? Come on. All right, there's 2 ways you can do this. You can either go f of -1 equals -1 plus 3, and we all said that is 2. Or I could look at the pattern going this way. What happens to it? It's going down 1. So that would be 2 and 1. Ah, you mean there's other ways to look at math? Yeah, it's called logic and order. It's not being ugly at all. I said the other day, like, this math class is going to be different for you because math is about problem solving and logic. It is. It's more about that than it is about the numbers. Okay? And I really, really want you to understand that. All right? So what I want you to understand today is I would like you to start going on both sides of the y instead of just going one direction, like 0, 1, 2, 3, 4, 5. Go -2, -1, 0, 1, 2. Why? Because I get to choose the inputs. Matter of fact, that's what the whole second half of your lesson was about yesterday. What was the second page about? Come on, I'm going to wait on you. I'm going to wait till somebody can tell me what it was about. Tristan?
Fractions.
Tell me the name of the second section.
Deciding on appropriate inputs.
Choosing appropriate inputs is what it's all about. Choosing appropriate inputs. Choosing appropriate inputs. See, I get to choose whatever I want to put in there for the input. So, why wouldn't I choose the easy numbers and the ones that make sense? I want to look at this function. F of x equals 1/2 x plus 1. Quick question, just so I get to know you guys a little bit better. How many people don't like that there's a fraction up there? Okay. Want to tell you, fractions are your friends, not food. Okay. They are good. Fractions are easier than decimals. And I'm sorry that your younger teachers didn't teach you that. I'm going to. I hope by the end of the year you won't be scared just because you see a fraction anymore. The hardest thing about fractions, and this is why so many people never get good with fractions, is the hardest thing to do with fractions is to add them and subtract them. Why? Because you have to have a common denominator. That means we've got to work with them until we have a common denominator. And it just takes time. It's not hard. It just takes time. And come on, we all have a tendency to be a little lazy, right? So we stop really working because the adding and subtracting is the hard part, and we're used to it being the easy part, right? But multiplying and dividing with fractions is actually easy. because you just multiply straight across. And with division, you just same change flip and you multiply. So it really is. And at this point in your career, we're going to do a lot more multiplying with fractions than we are dividing. But anyhow, I digress. I get to choose the values. Let's say here I chose, and I don't want to use those values because I just got done saying we want to go what? -2, -1, 0, 1, and 2. Because we want to go on both sides of the y-axis. Now, 0 is really easy, right? That's why we choose it. 0, 1/2, I plug it. I'm going to just speak through this, see if you guys can keep up with me, okay? If I plug in the 0 for 1/2, 1/2 of 0 is 0 plus 1 is 1. That was easy. All right, 1/2 times 1. It's a half, right? A half plus 1 would be 1.5. 2 times 1/2 is 1. 1 plus 1 is. Now, here's the cool part. Remember I said we can see a pattern, right? What's it going up? If I just look at my f of x's, it's going up by half, right? If I go to the right. So what would it be doing if I'm going to the left? Down by half. So what would -1 be? A half. And what would -2 be? All right. Well, that wasn't too bad because I gave you a nice easy fraction like 1/2, and we can still work with halves. That's not too bad. But do you see how it could be a problem? And now let's think about it if I had to graph that value. The 0, 1, that's not bad. And the 2, 2, that's not bad. And the -2, 0, that's not bad. But this -1/2, that's hard to graph, isn't it? Just like the 1, 1.5, that's kind of harder to graph. And if we had other fractions that was other than halves, it'd be really difficult to graph, wouldn't it? You see that? Okay, well, this whole thing about choosing appropriate inputs is, even though there's a fraction there, if I choose the right input, I won't have to deal with these. Watch. Let's say instead of using -2, -1, 0, 1, 2, I used 0, 2, 4, -2, -4. Let's say I chose those. I'll tell you why I chose those in a minute. But let's just say I did. We already did the 1. We already did the 2. Okay, let me plug in 4. 1/2 of 4 is, plus 1 is, I got a nice easy round number, didn't I? Do you see the pattern going up? 1, 2, 3. What's the pattern going down? Down by 1. So that would be 0 and, anybody? -1. Now I want to graph those in, I don't know, blue. So -4, -1. Hey, there it is. 2, -0, 0, 3, 2, 2, 2, and 4, 3. Look, it's the exact same line, isn't it? But I don't have any fractions in my input outputs, do I? Or at least not in my outputs. Because I chose appropriate inputs. Let me be a little bit more specific. Okay? You're going to deal with two types of problems today. Okay? One is fractions. Okay? Anytime you have a problem that has a fraction in it, the appropriate input that you need to work with is a multiple of the denominator. Anytime you choose a multiple of the denominator, you're going to end up with whole numbers. Okay? So anytime that you see a fraction, you want to choose the multiples of the denominator. Remember, the denominator is the number on top. Can you handle that one? So let me give an example here. What if the fraction had 1/3 in it? What values would you choose? I would choose 0, always still. Okay, and then what?
2.
3, 6, 9, 12. Positive or negatives of those. Okay, what if I had the fraction, I don't know, 2/5? What values would I choose? 0, 5, and I can use the negatives of those too, right? That makes sense? Can you handle that? All right, the other one that you're going to see is the square root function. Okay, this is a square root function. What is the square root? You know, it's the thing that undoes a square. When we talked about some specific numbers, okay, that had something to do with a square root, and those were the perfect squares. Okay, so if you see a square root, you want to use the perfect squares. Okay, now I have the simplest square root problem right here, and I would legitimately choose 0, 1, 4, 9, 16, 25, 36, 49. Remember that list I told you need to memorize? Okay, and if I plug those in, what's the square root of 0? 0. What's the square root of 1? What times itself gets me 1? What's the square root of 4? What times itself gets me a 4? Square root of 9 and 3, and square root of 16, 4. You see how easy that was? Now, if I try to use, I don't know, say the number 2 as an input, remember, all square roots except for those perfect squares are irrational numbers. We talked about those the other day, right? Those numbers have a decimal, it never ends and never repeats. It goes on and on forever. Those are crazy numbers, right? All right, well, it's not always going to be as easy as that. Sometimes it might look like this. X plus 2. We need to take the square root of x plus 2. Well, I still want to use those perfect squares, but I need to think of them differently. 0, 1, 4, 9, 16. Because now I don't just need those numbers, because watch what happens. If I plug in 0 plus 2, right, what is that? Well, 0 plus 2 is the square root of 2. Well, that's not a perfect square. I'm in trouble, aren't I? What instead I need is I need that x plus 2 to equal 0. Well, what can I put in for x to get x plus 2 equals 0? Yes. -2. So that would be my input. And then what can I put in for x to get x plus 2 to equal 1? I got 0. Now I need 1. -3. Nope, not -3. What plus 2 gets me 1? There you go, a -1. Now what do I need it to equal? I need x plus 2 to equal what? 4. So what plus 2 gives me 4? 2. Are you with me? I'm starting to lose a couple of you. That's okay. Stay with me right here. So now I need to find the what? The 9. I need to get x plus 2 to equal 9. What plus 2 gets me 9? 7. Now, what's the last one? X plus 2 equals 16. What plus 2 is going to be 16? 14. See, I just now chose these inputs. I used these to choose those inputs. Okay? Why? Why did you do that, Mr. Herman? Because now when I plug this in and I go f of -2 equals the square root of -2 plus 2. Well, -2 plus 2 is 0. What's the square root of 0? 0. Then if I do this next one, f of -1. When I plug that in, I get square root of -1 plus 1. I'm sorry, -1 plus 2, which is what? The square root of 1. And what's the square root of 1? 1. Now is it starting to make sense a little bit? Next one, and this is the last one I'll do, f of 2 becomes the square root of 2 plus 2, which is the square root of 4, which is 2. See how that works? And now I'm getting nice, round, even numbers. That's what we mean when we say choose appropriate inputs. Cool? Questions, comments, concerns, homework. 1.2. Anybody want to guess? Evens. After you do the evens, check them with a video. Okay? Excellent. Have a great day.